Along with the development of the times, technology, population, and human needs have increased. In 2040, Indonesia's population is estimated to reach 321.51 million people.
This condition resulted on an increase in demand for food or staples. One of them is the need for fertilizers. According to RNC research, the need for fertilizers is increasing every year. There's also a problem about conventional fertilizer that is more easily eroded by water during the rainy season. This condition needs to be handled so that we meet the demand so there is no poverty, hunger, and fluctuations in food prices.
Nowadays, agricultural technology is developing rapidly, so that it is possible for farmers to use nanotechnology to make more efficient fertilizers. The use of nanotechnology in fertilizers allows the release of nutrient in fertilizer to be controlled. Carbon nanodots are zero-dimensional carbon nanomaterial and have unique psychochemical properties.
One that has the potential to be used as a mixture of nanotechnology is leaf waste. In my hometown, Kudus is known as the city of Kretek, where there's accumulation of clove leaf waste so that clove leaf is less explored. So, here we are utilizing clove leaf waste to become a nanofertilizer mixture.
Therefore, we made an innovation entitled NitroClove Nanofertilizer Nitrogen-enriched seed-based fertilizer from C3 modified clove leaves.
The problem of this project are, what is the impact of ammonium phosphate, ammonium carbonate, and urea on the size, color, and stability of NitroClove nanofertilizers prepared from clove leaf seed, and how effective is NitroClove nanofertilizers on sprout growth.
My name is Qonita.
And my name is Baharani.
We are from SEMESTA Bilingual Body School, Semarang.
Then, how do you make the nanofertilizers?
Process of making NitroClove nanofertilizer. Starting from preparing carbon nanodots from clove leaves, first we collect clove leaf waste and we carbonize it with 800 watt microwave irradiation for 3 minutes. After that, we cut the clove oil and the ash. Then we mix each of them with aqueous to deionize the solution by the help of ultrasound irradiation for 30 minutes. Next, we prepare the carbon nitride. Citric acid is mixed to each of the variables used, then add distilled water to deionize the solution. Finally, mix with the help of vigorous mixing for 3 hours. After that, we prepare carbon nitride decorated nanocarbon fertilizer, mix all the pseudo variables with nanocarbon, then add aqueous to each of them to deionize the solution. When finished, save the solution in the bottle and the fertilizer is ready to use. It can be concluded that the average size of the C3 and 4 particles produced is in the range of 275 until 295 nanometers and dispersed with pi 0.359 until 0.486. Clearly, that C3 and 4 has been formed and successful. It is proved by CN based on sharp absorption peaks. But carbonate synthesis still has some impurities that cause a little unreacted precursor, that is the presence of the CO and CH2 groups that probably comes from citric acid.
And here's the performance of our nanofertilizers. So, we observe with various formulation, then ammonium phosphate is the better result with the height 30 until 36 cm. Based on our project, the combination of ammonium phosphate with citric acid performs a good characteristic of nanoparticles and good fertilizers compared to distilled water. We find that the use of seeded is slightly impact to the sprout growth, but then if you make it a hybrid, it will make the seeded clove result is better. And our method is considered effective because it economically saves time and water.
The strengths of our project are, it is easy to do and relatively cheap, and the fertilizer uses nanotechnology so that it can control the nutrient to the plants, and we're also utilizing clove leaf grease, especially in Qonita. Our project has the weakness of difficulty in maintaining a constant temperature. We replan it.
Our project can be used as a material for further research in the future. And the truth of our project is there are temperature changes and some moss while the seeds are growing.
In further research, the product should be purified first so there is no impurities, and the formulation needs to be tested in plant environment that is truly rooted so that in future it is better to use rooted plants. So that's all from us. Thank you for attention. If there are any mistakes, please forgive us.
And don't forget to support us in the final ISPO 2023.